Now, in this case, when you're dealing with arithmetic and you're given two terms, these two terms are not consecutive, so it's a little bit more work. So we're going to write out the formula twice and fill in the blanks. Everybody okay with that?
Yes.
Fill in the blanks. We know that the 13th term was 1181, and that has to equal the first term plus 12D.
Yes.
I think I did this one in class yesterday.
Yeah.
Wow.
So I had the exact same problem on my.
I did this one yesterday. I just realized that. Sorry. Any others?
Yeah.
What?
38 through.
Oh.
What? Wait, no. Because I already did 37.
38. Same thing. Start out with your nth rule.
Multiplication. That was wrong.
So when you have an arithmetic sequence, arithmetic series, and you got two terms of the arithmetic sequence, you want to write out the nth rule and then the explicit rule. The nth rule here, we're going to start by writing it out twice because you're going to have to form a system of equations. You know that the 10th term is 96, so I can write this out as 96 is first term plus 9 times d. I also know that the 33rd term is 326, which is the first term, plus 32 times d. I just shortcutted the distribute and combined stuff, but I screwed that up, didn't I?
I don't think so. Wait.
No, I
I
did.
know, but I'm good.
Yeah, for some reason I just thought I forgot to subtract one. So now I've got two equations, two variables. I'm going to eliminate the first term. In doing so, by this, subtract all this out. It's nice if you have that on your paper, isn't it? 0, 210,
230. 230.
940. And then 23. Your difference is 10, correct?
Yeah.
Okay.
I'm just gonna imagine.
If my difference is 10, in order to solve for the first term, I just re-substitute back in. So I know that 96 would be first term plus 9 times 10. So my first term is 6. Everybody okay with that?
Yeah.
Write out the explicit formula. The explicit formula is a sub n, first term, n minus 1. Fill in the blanks. We have a sub n is 6 plus 10 n minus 10. So we get 10 n minus 4. That's my explicit. Yeah, you gotta remember to simplify it. Okay? Now, the part of these problems that ask you, I think this one it asks you to find what, the 39th term, I think?
Yeah.
Use this formula to find your 39th term. Don't use recursive. Recursive to find an nth term is just awful. I would never do that. So you get 10 times 39, it's 390 minus 4, and you get 384. So you get 384 from
106. Was it
so
6?
39. Yeah.
36.
Yeah, be 386. Now, when you go to recursive here, yes, ma'am.
Okay, for the arithmetic sequence, and when you're writing the explicit formula, it would be wrong if you do like you don't combine the n minus 1 times 7.
Yeah, you always got to combine them. Right, you always got to combine and combine, or distribute and combine like terms. Your recursive rule here, yes, sir.
I was going to say, I did not simplify it for some reason. I don't know, I thought that you weren't supposed to, so.
Make sure you always do, because we always do.
Okay.
Okay, make sure you always do. The last part here is to write out that recursive. Remember when you write recursive, you just write out the a sub n, a sub 1, it's the a sub n minus 1. And what are we doing to each one of these individual terms according to the difference? Are we adding or subtracting them? So we would relate this out as each term is the term before it, and you add 10. And what was the first term to start at? So this right here is my recursive, and this right here is my explicit. Okay. Whenever you write recursive, you have to say a sub n equals a sub n minus 1 with whatever your difference is, or times your rate. But you always have to say where you're starting. Recursive rule needs to know your first term. That's really the only rules with it. What's that? Math is fun. Okay. With the rest of the stuff that's on here then, is really a good mixture of review problems. You'll notice that there's you've got two ratios, you've got summation stuff, what is the common ratio, number of n in the geometric sequence. Here they're doing, let me show you this. I want to look at a few of these to give you an idea. Remember what the vocabulary means for the instructions. This is where you guys will freak out when you see a test. I don't know what that means.
19.
Number 19. Determine the number of n in each of the geometric series. What this is asking you to do is find the sum of how many of these in this sequence is going to get me negative 65, 60. It tells you it's geometric, so are you going to use this one or this one? The one with the R in it because it's geometric. So you start out. You need to know your first term is 4. Your rate, how do you figure out your rate in this case?
Geometric, it's probably -3.
It's probably right.
Yeah.
Take the second term, divide by the first, remember that?
Yeah, guys.
Everybody okay with that? Now, in order to figure out the sum of how many of them is going to equal negative 65, 60, you just write out the formula. The sum, the first term, 1 minus your rate to the n over 1 minus your rate. We know first term, we know what the sum has to equal, and we know our rate. We just have to solve for n. Negative 65, 60 is first term times 1 minus negative 3 to the n over 1 minus the negative 3. What's that? Ooh, multiplied by 3. What's 1 minus negative 3?
4.
What's 4 over 4?
9.
In this example, doesn't that just drop out? In this case, it just happens to be dumb left and it drops out. Okay. Everybody see that? Okay.
And then you just divide by 4 and that's it.
Well, you don't have to divide by 4 at all, because you've got 4 over 4.
Oh, no, I mean after that.
No, you don't have to do anything here. Because what happens here is you get 4, whatever the numerator over 4, those just drop out. Okay, I'm just simplifying that right off the bat. Okay, I could have divided by 4, then I'd have to multiply by 4, and I'd still get the same answer where I started at. Okay. Now you have negative 65, 60 is 1 minus negative 3 to the nth power. How do you make this cleaner? I can't undo that negative because it's negative 3 to the n power. Okay? Now you saw this in some of the work that we've done when you had the logarithm stuff. And we talked a little bit about what this actually is meaning. What I want to do here is I'm going to move this negative 3 over here. It's minus a negative 3. So how do you move a subtraction symbol? Add it. I'm also going to add 6560 to the right. So what happens then is I have negative 3 because the stuff in the parentheses didn't move. I'm moving the sign in front of that, the negative sign there. Negative 3 to the n is 6561.
But if you added it, wouldn't it be positive?
No, because I'm adding the negative 3.
Oh.
Okay, I'm adding the negative 3. Here's where you have to start to think in terms of numeracy. You ever heard that? Literacy is being literate, knowing what words means and things like that. Numeracy is the same thing with numbers. Okay? Now, this says negative 3 raised to some power equals a positive 6561. What does that power have to be? What was it?
Even.
Has to be even. What? What do you mean what?
Why?
Well, when you have an even power, it means you're multiplying it like twice, 4 times, 6 times, right? So what's negative 3 times negative 3? 9. What's negative 3 times negative 3 times negative 3? Negative 27. See how your signs will alternate that way? So what I'm doing here is that I know that no matter what, my value of n here has to be even. So what I'm going to do is use numeracy and say the heck with the negative sign. Because it doesn't matter to me right now. If I take the log base 3 of 3 to the n and take the log base 3 of 65 to 61, I'm going to get n as an even number, 8. If you want to think of it that way, you can do that. Okay? Your n value here is 8. Remember, you cannot take a logarithm of a negative value. What I want you to think of is you're raising a negative number to an even power to create a positive number. Just think of it in terms of that's what I meant by using numeracy to help yourselves through it. Does that make sense? Do you agree? Negative 2 to the first power means negative 2. It's negative 2, right?
Yeah.
Okay. What's negative 2 squared?
4,
What's negative 2 cubed?
8, negative 8,
Negative 8
16.
times 2, get 16 times 2, get negative 32. Notice how your signs are alternating. Your signs are alternating because you have 1 negative, 2 negatives, 3 negatives, 4 negatives, 5 negatives. When you're multiplying even amounts of negatives, you will always have a positive value. When you have odd number of negatives, you'll have a negative value. Always, 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 always. So what we're doing here is that knowing that this number raised to this power gives me a positive value, that means by rule, this is even. Okay? That's all that is telling me. If this was a negative value, then that would have been a negative. It would have been an odd number. So what I'm doing mathematically is saying the heck with this right now as the negative symbol and just taking the logarithm. You remember to do the log base to get the exponent to drop? Just take the logarithm of a positive 3 because no matter what, it's going to give me an even answer. All right? It's just how that works through. All right? Is that clear a little bit more? Yes, ma'am.
So what if 6561 was negative? Could you put that in the logarithm in your calculator, or would that ever never?
It wouldn't work for this value because this one was negative. It wouldn't be, this would have to be an odd power of this. So if you raise negative 3 to the 7th power, what do you get?
A negative something.
Yeah, it'd be negative
Yeah.
some. Then it would be the negative version of it.
Yeah, but then like to go into like the logarithm, you
Mhm.
said it doesn't work for negative powers.
Yeah.
So how would you do that?
We don't worry about it. We don't,
Okay,
okay,
okay.
we won't worry about it. All right. This is the
Yeah, I was thinking the same thing.
this is kind of the weird scenario where you don't need to worry so much about logarithm, a lot of the logarithm rules yet.
Okay.
The only thing I want you guys to think of is even and odd exponents, what happens to positives and negatives, and then working out of that. That shouldn't be so bad. Okay. So in this, this last example then, I think we finished it. We got n is 8. Okay. Does everybody vaguely remember that for geometric using logarithm? Let's look at one that uses arithmetic. Let's look at 16. In number 16, this is an arithmetic sequence, and you want to figure out how many of them in this sequence would you have to add together for your answer to be negative 781. Now, when you worked with arithmetic sequences to find n, you always wound up with the nth rule. Remember that? Vaguely? Which means you want to write it in terms of n to start with. So we start with that. We know that our generic, our explicit formula, a sub n, first rule, or first term, n minus 1 times the difference. Well, they give you all that. So we get, what was it, plus 7, minus 7, so it's negative 7 and minus 29, I believe. Combining that out. So there's my nth rule. And I want to figure out how many of them do I have to add together to get to negative 781. Well, that's that formula.
Oh, wow, man. 116. I just had it.
No, I think it was the notion. Sad.
You more than you passed it. I swear I saw it.
Yeah, I thought I saw it too, but I guess it didn't know it.
Now you passed it.
It's weird. Probably
Is it
deleted.
down for that?
Probably delete a page. It's written in black. The whole thing's gone. That's weird.
There it is.
There it is. Huh. Un fantasma está en mi clase de matemáticas. I said there's a ghost in here.
In your man.
Clase de matemáticas. So fill in the blanks. We know that negative 781 has to equal n. First term here is negative 36. Nth term is that negative 7n.
Wait, could you just say the minus 7 and the plus?
Yeah,
Oh,
sure.
I see.
Yeah, it's fine. If you want to do that. And then it's all over 2. I see, said the blind man as he picked up his hammer and saw.
Oh, this is the stuff you did.
We did this a while ago, yes. That's why I wanted to do a little refresher here. Now, we all agree at some point in time you're going to have to do some factoring. Well, let's get rid of that denominator. What are you going to do?
Multiply by 2.
All right, double 781, I think you get 1562.
Yeah.
Negative 1562 equals, well, here when I combine out that numerator, we get n times negative 7n minus, was it 65?
Yes.
Yeah.
So I'm going to move this up. So I have negative 1562 is negative 7n squared minus 65n. What was the trick when you had leading term coefficient not positive.
Turn to the
Other
y
side.
equals.
Move it to the other side. Yeah, then we'll go to y equals. Good. So you moved the stuff from the right to the left. And I think you've already put it in your calculator. What did you get for your 0?
It's not moving. Oh, it's not there.
When you go to the calculator, your end value is 11. Yes, ma'am.
So is this zeros in the y column? Well, I'm literally still working on 11 to work and I can't do this part. I got it wrong every
A
time.
lot of times what you're messing up is you get to this point here and the signs get mixed up. Which one? Show me, I'll bet you I'll figure it out. Okay?
49 and 50. I don't
You typed it in incorrectly. Did you use a negative symbol, not a subtraction symbol? That is a huge mistake. Oh, what is your table set at? I've noticed that. If your x values are not going in sequence, if they're not going 1, 2, 3, or whatnot, what you want to do is go to, if you hit second table set. If you hit second table set, which is the window button, you have options for your tables to start. For some reason, mine's starting. It starts at 6.
That's what just happened in mine too.
And it changes by 1 each time. You can adjust these windows to be whatever. If you want to start it at 0 and have, or start it at -2, the table will start at -2 and it goes up by 1 each time. So in my table now, when I open it, first thing I see is -2, and it scrolls through. I do believe, I'm assuming most of you guys are probably in chem.
Yeah.
You do a lot of stuff with tables. I know you guys will use a lot of table stuff because a lot of times people come back in and go, I can't find my graph. I don't know what happened to my table. Because you forget how to adjust things, so it's not uncommon. Okay. Remember, the greatest buttons on this calculator is how do you wipe up the memory to reset it? Do you know how to do that?
Yeah. So,
Sir, can I get
second
0, 7,
plus
2?
7, 1, 2.
If you do those two things in your calculator, it kind of resets itself. So if you wind up with your axes have disappeared because you were in physics and you were doing something that you don't need the axis for, or you did something in chem and all the bad things happen, and carbon is friends with bromine.
I don't know if that's true.
You're not allowed to use this calculator.
I know. I've heard.
But I don't even know how to program something in this calculator.
There's a lot of people do that.
Like, I didn't even know that you could do that.
I didn't know it existed until you told us.
You can actually download video games for these too if you wanted.
How long till we can text them?
Pretty soon, I would imagine.
Oh, you
And now, what I didn't realize is now that they have these smartwatches, I'm gonna have to start putting in my syllabus. You can't have a smartwatch in my classroom.
Oh, yeah, this.
Oh, the new iWatch or that one that
Yeah.
There's so
A lot of those, because you can download, you can go to the internet and all that stuff on your phone, on your watch,
Yeah.
because you need to.
No.
It's lame.
We should carry around these. I don't understand, like, no. What's the help?
I don't see why you
It's like you're taking.
I like this quote from Apple. They build stuff that you didn't know you wanted. Yeah, I know. Think about it. They build stuff you never thought you would want.
Like,
I don't want that.
Well, how many people in a million years would have thought about an iPod? I mean, you never thought anybody would ever want one of those things, those little MP3 players, but way back when they first came out with them, everybody wanted it because, oh my God, that's awesome. And then it started to be, all right, well, then they made this. They made those tablets. Tablets? Why do I need this on a computer? And then all of a sudden, everybody's using them like, yeah, these things are awesome. Apple makes stuff you never thought you would ever want. And that's how they market it.
Except they actually make things that are like, it's like really big and ugly.
Yeah, it's really,
Why would somebody want that?
All right, guys, you got time right now. Continue working on this. This has got a good mix of what to expect on the test. I'll just wander around and help you out, okay?
work on the whole thing.
Yep. Wait.